Okay, now that we've looked at some basic data structures, lists and sets and dictionaries, we want to know how to aggregate them. So we already know how to do little aggregations of lists by initializing an empty list and then appending within a for loop. But oftentimes we're doing very simple operations and we don't need this whole setup of initializing something and doing something if it's a very simple something. In Python, there are these things called comprehensions. The most common thing is a list comprehension. And it's a neat little construct that will considerably reduce the number of lines of code you need to perform small acts of collecting or aggregating data. In addition, under the hood, Python can do some optimization, so often this can be a lot faster, particularly for large collections, than doing it with a for loop. So here's an example that constructs a list of squares. I can make z. I'll start with my list literal, and I'll have I, using Python power to 2 notation, I squared, but I hasn't been defined yet. However, in line, I'm going to make this 4. So for I in range of integers from 0 up to and not including 5. And that's what I do. So let me examine Z, and we can see that it's for every number in the range from 0 up to and not including 5, we take the square of it and we collect it into a list. Very compact. You can also add in conditionals, like requiring only even numbers. So let's say z is I squared for I in the range from 0 not including 5. Let's do up to 10. If I modulo 2 is equal to 0, so it's an even number. Let's go ahead and just have z printed out at the end of this. There you go. Square of 0, 2, 4, 6, and 8. So the general form here is the list literal, and we have an expression for variable in collection if conditional. That last if part is optional, of course. Let's start with some simple parsing of a list of words. So we're going to get the lengths of words in the standard Unix words file. Now we've loaded this already in MP Workshop data. So let's import words. And let's go ahead and slice out the first 5 words just so we can see what this is about. Okay, it looks like this file parsed 1 word per line and included the new line characters. I think that shouldn't matter for our purposes. So let's do counts. We'll do a comprehension and we'll get the length of word for word in words. Actually, this won't work, will it? Because we will get an extra /n for each thing. So let's actually go ahead and get rid of that part. So if I take words and take word 0 and go back up to it and take, okay, I'll introduce a new thing. I was going to use slicing, but actually we can use the strip method on strings in order to get rid of all white space characters on either side. So the first thing we're going to do is do a little bit of processing here, and we're going to say word strip for word in words. And then let's print out those first 5 words. Much better. Good with the help of a list comprehension. Now let's get counts. So we're going to have the length of a word for word in words. And that will give us the counts of every word. So what's the length of counts? There are 235,000 words in the file. This is the same as the length of words. And what is the maximum word length? Well, let's use the max it built in, and we'll take the max of counts. So there's one word that's 24 characters long. Now let's do some simple math and calculate the average and standard deviation of the word counts. And again, note, this is for illustrative purposes. For example, the NumPy library has efficient built-in functions for calculating statistics of collections of numbers. This is just for us to learn a bit how Python works. So we can import the math library. And let's compute the average word length. We can sum the counts and divide by the length of the counts. And so our average is a little under 10 letters. The variance would be the sum of this list comprehension, where we want x minus the average, take that squared for x in counts. So see how this becomes nice using a list comprehension. And we can divide that by the length of counts. So the variance would be that. And finally, the standard deviation we can use the square root function, which is not in the not a built-in, but you just import it from math, which is in the standard library. Great, so now we can print the average and say plus or minus standard deviation. So we have some basic statistics of words in our file. Finally, let's add in a conditional. Let's get a count of words that are longer than 10 letters and that end in Y. So here's a special count. What we're going to want is the length, because we're counting the number of words that are longer than 10 letters and that end in Y. And so we're going to want words, but they're on a condition. So word for word in words, but if the length of the word is greater than 10, we said, and we'll use a built-in string method here, ends with Y. So you can see it's really useful to look into the Python standard library because there are a lot of common methods and functions on basic data types that can really help you out. So the special count is 12,446. Great. So you can see the above is more compact and can sometimes be, I would argue in this case, is more readable than something like count equals 0 for W in words if length of word is greater than 10 and word ends with Y. Add to the count. And print the count. Okay, in addition to list comprehensions, you can also do comprehensions on sets and dictionaries. They allow us to quickly connect unique keys and associated values from a collection. Here we're going to get into a little bit more of what this workshop is about, material data. So I am going to import our data here. So from MP Workshop data, we will import crystals, and we will just show what that first crystal looks like. So it's simply a dictionary, nothing special. The keys are space group, elements, chemsys for chemical system, and what we call pretty formula, which is the reduced cell formula. And we can see that the value of space group is itself a dictionary with the keys, number, and crystal system. We can see that the value of elements is a list with element symbols as elements, etc., etc. You can also maybe notice from an earlier lesson that chemsys is simply a hyphen.join of a sorted list of the elements. I think elements is sorted as well. So let's use a set comprehension to find the unique values of space group crystal system among our crystals. So we can say crystal systems. We're going to form a set, so we can use the literal creator for a set, the curly brackets, and we can say it's going to be the value of C space group, where C we're using to denote a single crystal, space group, and then reach into that, the value of space group, which is a dictionary, and go ahead and get the value for the crystal system key, which for the crystal above is cubic, and we're going to want to collect these for C in crystals. And because this is a set comprehension and not a list comprehension, it's going to throw away values that are not unique. So if we print out crystal systems, we only get these values. If we look at the length of crystal systems, we see there are 7. Great. What I intended to write there is the length of crystals, so that we can see that there are 23,000 crystals in this little sample set. And instead of getting 23,000 crystal systems and then having to sort them, we just use a set comprehension just to get the ones that are unique. Now, let's say we want to reorganize our collection of crystal data to facilitate efficient lookup by, say, formula and crystal system. So we want to be able to, given a formula and crystal system, go right to the right thing. We don't want to have to iterate through our entire list and see, okay, what's the formula, what's the crystal system? A dictionary comprehension can do this succinctly. So let's create this crystals new dictionary in this case. And it has the same notation as the set comprehension, but you'll see the first element will be a key colon a value, just like a dictionary. So we can say C pretty formula and C space group crystal system. Oops. And because this is going to be the key of a dictionary, we learned before that tuples are immutable, so they can serve as keys of a dictionary. So let's go ahead and make this a tuple of the pretty formula and the crystal system. And we use the colon to indicate this dictionary relationship, and the value will just be the crystal itself. And this is going to be for C in crystals. Notice that because I have these outside delimiters, Python knows how to interpret this. I don't need this whole thing on the same line. So now, for example, if I want to find my crystal that is cubic gold, I can use a dictionary lookup with this tuples. Let's look up silver. Silver, cubic, what is that? Boom. So now we have a question. Is there an entry for cubic gold? Go ahead and do that, and I'll do it after you. Okay, is there an entry for cubic gold? Well, gold cubic, since we know that it's a set, is this in crystals new? True, great. Okay, now for an exercise. We are going to comprehend alkali metal halide crystals. The PyMetGen Materials Analysis Library provides an enumeration of chemical elements via this element class. Element is iterable, yielding one chemical element at a time, where the object representing each element has some useful properties. For example, let's say from PyMetGen import element. Oops, there we go. Halogens. Create an empty list. For E an element, if E is halogen, then halogens append E, and let's print halogens. Here are the halogens. I purposely in this case didn't use a list comprehension, and if you were annoyed by that, then I'm happy for you. Okay, so in this exercise, read over the following code to understand what it does, and then see if you can refactor it along with the above code to be more succinct using list comprehensions. So here we go. Collects halogens, and then halide systems are, well, I'll have you read through this and go ahead and see if you can refactor this to be more succinct using list comprehensions. I'll wait. Okay, now that you've gone through and done that, let's go ahead and refactor this together. So, for PyMetGen, from PyMetGen import element, looks like halogens can be E for E in element if E is halogen, and let's see, we have halide systems, and what do we have here? For H in halogens, we're going to create alkali metals. For E in elements, we're going to create this list of alkali metals, and okay, it's a little complicated. Let's do one thing at a time. So for halide systems, for H in halogens, this alkali metals thing seems pretty straightforward. Let's go ahead and do that. E for E in element if E is alkali. Okay, that looks good. And then for M in alkali metals, we can sort of do this and append halide systems. Okay. Okay, we can actually probably just create that right here, I believe. Halide systems are going to be this chemsys value. And this is going to be for M in alkali metals. Great. Now we have these halide crystals. Okay, and we're going to append there. So that looks like a pretty straightforward comprehension. C for C in crystals. If C chemsys in halide systems. And finally, we have the comprehension over formulae, where we're going to get the pretty formula for C in halide crystals. Great. So let's go ahead and run this up here so we can see what our output is. And let's see if we get the same thing. Let's call this formulae 2. And let's assert that formulae 2 is equal to formulae. Great. This works because we do everything in order. Elements have a certain order. We can also assert that the set of formulae 2 equals the set of formulae. This would be order independent, just as valid in this case. So great. A note for the adventurous: you can nest 4 headers in a comprehension. So for example, formula 2 right here, we could say, well, C for C in crystals. I'm not going to attempt it right now because it's not necessarily readable. But essentially, you can do something like expression, for variable 1, and collection 1, for variable 2, and collection 2, if conditional. And this is actually going to be the same thing. I'll translate this code to be a raw cell, so it doesn't have to be evaluated. This is equivalent to for variable 1 in collection 1, for variable 2 in collection 2, if conditional expression, where you're actually collecting that. You can see how things are a little bit out of order. Sort of the conditional is at the end, and the expression is up top, but it sort of follows the same pattern down. It could impact your readability, so you can go a little crazy with comprehensions. I don't recommend that. The point is for it to be more readable. Programs are written for people to read and only incidentally for machines to execute. Keep that in mind.